Hi everyone, welcome to our channel from DSA to Dev. In this video, we will be focusing on jump game. It's a very popular question on Leetcode. In this question, you are given a list of numbers, positive and zero might also be a number here. And what you have to do, you have to start from the first element of the array and you have to travel up to the last number of the array. Okay, let's take the example of this list here. Let's say you are starting from this number 2, right? 2 is your first number. So in this particular problem, what you have to do, you have to just find out whether you can reach the last element or not. Okay. All right. So what you can do, let's say you are on this number, on first number, which is 2. And what you can do, you can jump up to a maximum length of 2. Okay. So basically in this particular problem, you can starting from 2, you can jump to this one number. Okay. And once you reach this number here, now you can jump again with a length of 1. Okay. And then again you can jump with a length of 1. So now you reached on the last element. So you don't have to jump further basically. You just have to check whether you can reach the last element or not. All right. And here, if you can observe, there might be some scenario where you will not reach up to the end of the element. Okay, let's take this example for now. If I had 0 here, right? What could be my path? Let's say if I start with this 2, I'll take the maximum length. Okay, and then again I jump with length 1. Now you won't be able to jump further because your jumping capability is now 0. All right. So what you can do, there is another way to reach here. You can start from this 2, and instead of jumping a length of 2, you can jump a length of 1, right? And from here, you have a jumping capability of 3. So now you can directly reach your last element here, correct? All right. So this way, there are so many possibilities, right, to reach the last element. And there might be some scenarios. Let's take another example here. If I had this 2 here and this 3 here, okay? So with this 3, where I can reach, I can take a maximum jump of 3. So I'll directly reach to this 0. Now I can't go further, correct? Now instead of 3, let's say I took a jump of length 2. Then from here, I will again end up on this number 0, correct? Now I can't go further again. So if I take a jump of length 1, then from here, even from here, I will reach on this 0 only, correct? So in this particular example, our jumping is not possible, basically. All right. So in this case, we just have to return false. And if you can reach up to the end of the array, you can just directly return true here. Okay. So basically, there are multiple variants of this question, jump game. I know there are 8 of them right now. In this particular problem, you just have to tell whether you can reach till the end or not. Okay. So in other variants, there could be another problem. Let's say you have to reach till with minimum number of jumps. There could be another problems as well. So in this video, what we are going to do, we are going to solve this via 2 solutions. First, we will be using dynamic programming. Okay. And in the second solution, we will be using a greedy algorithm. All right. I'll tell you one by one. And what eventually we are gonna do, we will be focusing on both these solutions. For each of them, we will be writing code. We will be checking time complexities. Okay. All right. So in dynamic programming, what you have to do, you have to check each possibilities, right? In this particular example, what you have to do for this first number 2, you have to check each jump. Okay. All right. So now once you are jumped on this number 3, this becomes a new problem for you. Okay. Now you have to jump from 3 another positions. Okay. and wherever you reach the maximum, wherever you reach the last element, you can just return from there. Okay, and then you go further for this one. You go there. From there, you can go here. So this way, you have to basically check each jump. Okay, and how exactly we are gonna do? We are gonna do it via recursion here. Why exactly recursion? Because what we are doing, we are jumping to a new number and making that new number as our new problem. So basically, we are just repeating the same process again. All right. Okay. So let's start with the coding here. So I took this example here as the numbers, and what we are gonna do, we are starting with number 0, right? So let me write a different function because we are writing recursion, right? And we will be returning a boolean, and let's name it as start jumping. Okay, so we are basically starting from the zero, from zero. All right. So what we are gonna take inputs as parameters. We are gonna take numbers, our basically our array, and then we are gonna take current index. Okay, current index. All right. So we will start implementing here first. Let's take a variable here. Okay. So you see, I started with 0 because that was our our main agenda. And you can see this is throwing me an error because I'm calling it via from a static method. So I have to make this as static as well. All right. Okay. So what I have to do, I have to travel my this array starting from current index, right? Why exactly current index? Because every time when you are reaching a new number, you will be starting from your jump from there only, right? You are not gonna go back and again start jumping. You will be jumping forward in the array. Okay. So, and till where you are gonna jump, you are gonna jump your current index, basically from where you started, plus now where you will be going till your current number. Okay. And you will check each jump. Okay. Uh, Now if you will see where exactly I'm starting at 0. Okay. So where would be my next jump? My next jump would be at least one number forward, right? At least one number ahead. Okay. All right. So instead of current index, I will be starting with one additional position. And then because I have to check all the numbers, basically, let's say 2 was your maximum number, right? So you started with 0, and then you started your first jump at 1, and you also have to do one more jump, right? At jump at 2. So for that, you will be adding 0 plus your number 2. So it should be equal here, right? You are basically you are checking your last index as well. All right. Now what we are going to do, we will be storing this into a boolean, can reach. Okay. And gonna do, we will be calling this method again. Correct. This time we will be taking I here. Okay. So basically we are checking each jump here. So basically we are checking each jump here. So we will be starting with I now. All right. Let me just declare it outside because I also have to return something here, right? So it's better, let's start this here, initialize it here, and then we can just return whatever we fetch it here. Okay. Or we can do it this way also. We can return false here. All right. And you don't have to declare a variable here. Every time you can just take a new variable, and you can check if my can reach always returns true, then you can simply return true here. Okay. So this way, basically what you have, let's say you start jumping, it returned true to you. So basically you already reached till the last element, right? So what you have to do, you have to basically return a true somewhere, right? We will be returning it here. If your current index is greater than or equals to -1, then we will be simply returning true. Okay. Now let me just explain it to you why exactly I did this. Now let's say somewhere you have a element, uh, your element is 4. Okay. Now you are just on the second last element. So by taking a maximum jump, there is a possibility that you will be going ahead, right? Basically, you are just moving ahead of the array size. So in that case, it is also true, right? Because you are already reached last element. And somehow, if you are already on the last element, you can just simply return true, right? Okay. Now we are already returning true. We are already returning false, but there will be one more scenario, right? Where you can't travel jump further. So if you remember, I told you when your current number is 0, then you won't be reaching your end of it, correct? Now you can see I wrote this one after this condition, right? Why exactly I did that? Because when let's say there might be some scenarios where your last index number is 0. Okay. So in that case, if you write this first instead of here, you will be writing this first. It will return false to you, right? But you are already on the last number of the array. So why should you return false? Also, let's say your current index somehow reached uh, more than the length of array. Let's say your array length is 5 and your current index is 7. There might be some scenario where you will be going out of your index. In that case, you will be getting array index out of bound error, right? So to avoid that, we will be simply writing it here. Okay. All right. So let's run this and check what is the output. So I haven't printed it yet. So let me just print it out. Okay. Let's run it again. All right. You can see we are getting true as a result. So basically that means we can reach to the last element, right? Let's take an example of a failure case where we were not returning till the last element. Okay. Now, if we run this, you will see we are getting false, right? So that means our program is working fine. All right. So let me just revert it back here. So now you see we have just written the recursion method. It's not a dynamic programming from anywhere, right? So for that, I can just explain it to you quickly. Why exactly we need dynamic programming here? So let's consider this scenario. You are let's take example of this one here. Okay. So what's happening? So when you are starting from this number 2, you can reach here, right? And from here you can reach here. So now you are already evaluating this number 1, correct? Now there could be another scenario when you are reaching starting from this 3 again, then you are going here. From this 3, you can also directly go to this one, right? So in this case, what's happening? You are calculating this one again, correct? Now there will be another scenario when you will reach here. Now you can also see from this 2, you already reached this one previously, and you are again reaching here. So you are calculating this one again, right? And from this one, you will be going here again. And now you are calculating this one 3 times, correct? So in this way, you are just checking already calculated value again. So to avoid that, what we have to do? We have to do memoization. So in a recursive function, when you write a memoization, it becomes dynamic programming, right? What is the basic concept of dynamic programming? We store the previous result and we use it to calculate the future result, right? So let's implement the dynamic programming here. So let's start with the memoization. I will be declaring one integer array memo. Memo means memoization, right? I will be initiating it here. Okay. This is giving me an error. Why? Because I'm again using it in a static method, right? Mhm. I'm using it in a static method, right? So for that, I have to write a static keyword here. Okay. All right. So now someone can ask me why I did integer array here, not a Boolean array. Uh, because we have to return Boolean, right? So we could directly store our answer there. So now let's assume in a Boolean array, you will be having two cases, right? True or false. By default, it always false when you have a primitive data type of Boolean, and it will be either false or true. But let's say there is a scenario which is you already calculated, which returns your answer as false, right? But false is also your default value. So how you are going to distinguish that? So to avoid this, we can use integer array. I will be keeping 0 as a default value. So basically 0 means that it didn't evaluate yet. And for 1, I will be keeping it as a true. Okay. And for 2, I will be keeping it as false. There can be another ways to do it also. I find this way very simple to me. Okay. All right. So what is the basic concept of memoization? Wherever you are starting your current, another recursion. So before starting that, you just have to check whether your memoization is not filled with default value. So instead of I'll be using here current index, right? So what you have to do, you have to check whether your memo is equals to 1. Okay, and you can simply return it. So you already checked here that it's not 0, correct? So that means it will be either 1 or 2, correct? So let me just write it here. Return 1 for true and return 2 for false, correct? So this condition, what it will check whether your value is 1. If it is 1, it will be returning true, right? If it's 2, then it will be returning false, correct? All right. And now what is the next point? On the next point, you have to just store the value after the recursion wherever you are returning the value, okay? So in this case, we are returning true, right? So we can just directly write 1. Okay, because I'm returning true, that's why I wrote 1 here. And I'm also returning it here. Let me just write it as 2 here, right? Because for false, I have to store a value of 2. Okay, so in this case, we can just simply check our example. It is returning true. Let's cross check our example once. I'll be writing this 2 here, 2 here, and this 3. Let's run this and check. This is the case where we were getting a false, right? Okay, so we are getting false here. Okay, so this was the case of dynamic programming. You can see how exactly we wrote the code. Let's check the time complexity now. Okay, so what you are doing for each number, you are basically going up to whatever the value of the number, right? Okay, now let's say in worst case scenario, 5 is our array length, right? And 10 is our integer value of each number. Okay, so what you are doing for first number, you are checking it 10 times, correct? You are jumping 10 times, and for each number further, you are again checking 10 times, correct? So for n numbers, you are checking, let's say in standard scenarios, we say maximum value of the n could be n, correct? So basically what the time complexity we are having n square. Okay. Again, it's not a very optimized solution. It's just a dynamic programming. I told you we are doing dynamic programming because it can be helpful in another questions, another variant of jump game questions. All right, now let's move to our next solution, which is greedy algorithm. Okay, so in this greedy algorithm, what you are checking at each step, you are checking your jumping capability. Okay, current jumping capability and the previous jumping capability. Now you are starting with a variable jump. You are starting it with 0. Let's say initially you have 0, right? We can take the example of this number here. So when our I is 1, we are on this number, right? 3. So at this step, we will be checking what is our previous jump. So in the previous iteration, when our I was 0, our jump was 2, right? But we already took one jump by reaching to 3. So our jump now would be 1, right? And our number is 3, current number. So in this scenario, we will be always taking the maximum capability. Okay. So we will update our jump as 3. Okay. And now what you have to do, you have to check whether your current jump is 0 or not. Okay. That was the only failure case, right? Where you were you were not able to jump further. So there might be some scenarios where you from the previous jumps you exhausted all your jumping capability, and now you are reaching to the new position, new number, which is also 0, right? So in that case, you can just directly return false from there. Okay. And now what you have to do, you have to decrement your jump also, because on every iteration you are just jumping one position, correct? And now if you are end of this for loop, you already reached to the last position, right? So you will be returning true directly. Okay, let's type the code for it. So I can simply comment this dynamic programming code here. We don't need this one. Let's take the example here. I will initialize my value jump with the value 0. Okay. Sorry, I will be writing it as a int. Now let's start with index 0, and we will be traversing it till the last element, right? Let me just tell you why I wrote -1 here. Because once you reach on the last element, right? It doesn't matter what the value of the last element is. Last element can be 0 or any positive numbers. I don't care, right? We just have to reach to the last element. So we can just skip evaluating the last element, and we can just simply travel till second last element, right? Okay, now what you have to do, you have to check which one is the maximum value, right? Your jump from previous iteration or your current number. Of course, for 0, it would be always your first number, right? Because your number would be higher or equals to 0. Now we have to check if my jump is 0 already, then I can simply return false from here. So basically, you don't have to return it here in this case. You just have to, let me just take one boolean here, which I will be starting with false, and let's start it with true, because here we are giving it as false because our jumping capability is 0 now. We can't go further, right? So in that case, our answer would be false, correct? And now once we already got at a position where we can't reach further, we can simply break our iteration, and that was our answer, right? Okay. So let's check for this example. In this case, you know, there is no possibility to reach until the end of it. Okay, we forgot to decrement our jump, right? Because every iteration is is particularly a jump, right? Whenever I'm moving to next element, basically, I'm just jumping it. Okay. Now let's run this and we can see we are getting false, right? Okay, let's just cross check it with another example once. Okay, now let's check this one. We are getting true in this case, right? So this way we can follow the greedy algorithm. And of course, you are just traversing it once, right? You are just starting from 0 and you are traversing it up to second last of the element, second last element of the list. So in that way, it's just of and linear time complexity, right? So in this particular example, uh, greedy algorithm is the most optimized solution. Okay. All right, that's all for this video. I hope jump game is pretty much clear to you. Please leave a comment if you have any doubt. Thank you. Bye bye.